Hello everyone, welcome back to our this lecture series on the electricity, magnetism and electromagnetic theory. This is all lecture series dedicated to the various aspects of electrical and conductivity of various components, materials and so on. So today's lecture is dedicated to the electrical conductivity, and this is lecture is having highly application regarding the materials conductivity, properties, behavior, that whether they are electrically conductors or insulators or having the behavior of semiconductors, etc. So let me start with the definition of the electrical conductivity. As we all know that the electrical conductivity is a measure of how easily a material allows electric current to flow through it, or the current can be easily flow through inside this material. So for example, in this image, see, this is the copper material, current is flowing, that's why this LED is glowing. In the case of glass, the LED is not glowing. In the case of steel, it is glowing. So this is how that whether this material is conductor or insulator, this is how the electrical properties works inside any material. It represents the material's ability to conduct electrical current, whether the conductivity of electric current is there or not, and this is how we can define that the material's electrical property. So let me start with the free electron theory. So here we are taking the example of any material which is having the atomic number. So these are the atomic structure of any material. Same structure every material follows, but depending on the number of particles there. So this is the example of copper. So copper is having 29 particles. See, copper is basically having 29 particles. See. So for these 29 particles, these are the orbits there. As we all know that this is the atomic structure in which this is the nucleus, nuclei, which is having positive particles, proton, and neutral particles, neutron. So nuclei is there. These green particles are can be considered as proton, and while this pink particles are the neutrons. Neutrons generally are not having any charge, while protons are having positive charge, positive equivalent charge as compared to these outermost electrons. These kind of blue color particles are the electrons. Electrons generally found on the orbits. They are not inside the nucleus, they are always in the outermost core of any material. See, these are the orbits. So this is the orbit 1, orbit 2, orbit 3 and orbit 4. So the numbering actually we are giving because of the formula 2n square. The meaning of 2n square is that the amount of electrons or the number of electrons in orbit. For example, for the first orbit n is equals to 1. So definitely 2 into 1 square equals to 2. So in the first orbit we will have only 2 electrons, see, 1 and 2. While in the second orbit, obviously 2 into n means 2 square equal 4 means 8 electrons. See, 1, 2, 3, 4, 5, 6, 7 and 8 electrons. Similarly for the third, 18 electrons. So this is what the filling patterns of orbit 2, 8, 18, 32, which is following the formulation of 2n square, where this n actually is the orbit number. So this is how we can define any atomic structure, and this is the basic kind of explanation of any material. Fourth orbit, it is not necessary to have all the electrons there. They can be less, but the maximum amount of electrons in first orbit is 2, second 8, third 18 and fourth 32. So the number of electrons cannot exceed that value, but can have the minimum value between 1 to 32. So that's why we are having single electron in the outermost core. Why this single? Because the atomic number of copper is 29. So for this 29, in first orbit 2, in second orbit 8 and in third orbit 18. So 2 plus 8, 10 plus 18, 28 and single remaining electron in the fourth orbit. So this is how the 29 electrons has been distributed or placed inside any atomic structure. So electrically, if we are taking the example of this copper, 29 number of electrons are equals to always 29 number of protons. So electrons are having negative charge E minus, while protons are having positive charge P positive. Naturally, always these materials follow this structure. Number of electrons are always equals to number of protons. So naturally every material is electrically insulator, means there is not any charge inside that. For the definition of this charge, you can follow the previous video. This is dedicated to the definition description of the charge materials. Now, so for the charge or making this particle or material a charged material, so it has to be some disbalancy there. It means that number of electrons must not be equals to number of protons. There is some difference. So this how we can create that difference. Inside that nucleus, positive protons are constantly putting force. Obviously the opposite charge attract each other. So these positive positive protons are putting force, the attractive force, on the outside electrons. So that's why they are continuously put it on that particular places, and due to the repulsion of electrons, they are not going to attached within a nucleus. They are having certain distance and place, and they have to follow it. And as we all know that this nucleus is also not constant, it is also spinning, and because of the spinning of this nucleus, we are having the revolving of electrons around these nucleus. So or in orbits, they are not stationary, they are continuously rotating, revolving in these orbits. So because of this rotation, there is some movement there in always in electrons. Also, the electrons which are nearly to the nucleus will have the maximum amount of attraction force, while the outermost electrons in the second, third and fourth will feel the less and the least amount of force. So we can say that the electron in the fourth orbit is having the least amount of attraction force as compared to the third, second, and while the first orbit is always having the maximum amount of attraction force. So by this definition, we can say that this electron is feeling the least amount of attraction force, so that if we can apply any amount of additional energy or some forces there, some pressure there, so they can come out easily. How? First of all, we can put a photon on it, so the electron can absorb the energy of photon. So this is how the electron can get energized. The second, we can provide some temperature to it, we can provide some heat to it, so that that heat can also be absorbed in the form of energy. While also we can compress this material, so the force is there. So because of this force, the pressure will apply to this electron, and some other process also. This is how any one of the process can be there, and the electron can come out easily from this orbit. So see, if this electron, we can say that we are giving temperature to it. So because of the temperature, this electron will absorb the amount of heat, and because of the heat, this electron will start vibrating. The meaning of vibration is that since it has absorbed some heat, so it has to consume this heat, it has to transfer this heat to another form. So because of this, it starts vibrating on its place. See, in this place it will start vibrating, and because of these vibrations, thus the movement will disturb this revolving portion of electron, and all of a sudden, when the energy level gets maximum, this electron will come out from its place like this. And because of this releasing of this electron from this place, we will have a vacancy here. How? Since there is an electron there, so there must be a position of electron that has to be held, and because of holding this this position, electrons are having negative charge, and this negative empty will create some positive charge here. In this position, positive hole will be created there in the equal magnitude of electron. And obviously this electron, when it is coming out from its orbit, it will move something like this. Means we cannot predict the direction, it can go anywhere. Remember, first and foremost, when electron is coming out, we cannot predict its direction, whether it will go in north, south, east, nothing, can go in any dimension. Also, we cannot predict the velocity of this electron. Means it can go inside the other orbits also, it can go outside through some other materials, and so on. So this is how we cannot predict any of that behavior, motion, movement. That's why the name is free electron. The word meaning free, it means that it is completely free to whatever. For example, free to move, for example, free to around something, free to roam something, free to get inside another orbit, or free to get inside another material. We cannot predict. Free means complete free. So this is what the meaning of free electron. The electron which is coming out from this orbit having some random zigzag without any predictive direction movement, and because of this the material is going to be unpredicted. The meaning of unpredicted is that because of the movement of this electron, obviously we are also having surrounding these kind of molecules. See, atomic structure. This is not a single structure, multiples are there. In the case of solids, atoms are completely overlapped on each other, while in liquids they are having some distance, and gases the more amount of distance, but we are concentrating only on the solids. So solids, the atoms are almost overlapped each other, and when electrons from one orbit emits out, it can also disturb the motion of other atoms also, can collide with other electrons, can collide with the nucleus, can collide with anything. So kind of disturbance is created in this material, and this is what our target is, to get material to be conductive, or the conductivity of electricity, this should be there. So this kind of disturbance is required to us. So see, this electron has been come out obviously, and having some this random zigzag motion, and this motion is known as the Brownian motion. The scientist Robert Brownian has discovered this. So on honoring his name, this motion is known as the Brownian motion. So electron has been come out, and obviously it is having the charge of minus E minus, electron minus, and this hole is also having the positive charge. This electron is going like this anywhere, and in the search of this electron, this whole, remember this whole atom will also start moving, and we can imagine that this amount of structure, if it is moving, and because of the collision with other material, definitely this will create a huge amount of disturbances there, and because of these disturbances, multiple free electrons will generated there, and multiple free electrons if generated there, so multiple positive holes will be generated there, and this is how we can have the motion of particles inside of any material, and this is what the free electron theory. The meaning of free electron, that electron has been come out from their orbits, electron has been released to their positions because of the absorption of energy, and once they come out, they will feel like free birds, and because of the word free birds means they can roam, they can travel, they can move, they can do whatever, anywhere, any direction, anywhere. Free electrons, and because of these free electrons, the materials has been get charged, and because of this charged portion, the material can conduct or can pass through electricity inside it. How? See, for example, we are putting this atom inside any box, we can say that. See this box, and we have connected this box with positive battery and negative also. So we can say that these are the two electrodes we have taken, the positive one anode obviously, the negative one we have taken as the cathode. Obviously this atom is there, and this is the free electron we are having. Obviously this whole atom is having positive charge, while this electron is having negative charge, and as we all know that same charge will repel each other, while opposite charge attract each other. So in this case, because of this positive portion, this atom will get repulsive force, and it has to move in this direction, and negative electron has been attracted by this electrode and repulsive by this cathode. So it has to move like this. So we can say that the positive particles are flowing from this place to that place, while negative charge is flowing from this electrode to that electrode, and this is how the particles has been flowed from one end to another end. And this whole material, we can say that if we can make this material like this, So this can move, or we can say that the movement of particle, if we are connecting this as the positive anode, this as the negative cathode. So the positive holes can flow in this direction, while the negative electrons can flow in that direction. So this is how the particles can flow easily from one electrode or orbit to another. And once the electricity, if we come to that our point, the electrical conductivity, if particles are flowing from one end to another end, or vice versa for the other particle, so we can say that the electricity has been flowed from this material. How? Let me give you an example. See, if we are having copper, we can take the example of copper because we are discussing copper only. This is the copper material. Okay, copper wire, we can say anything. Let me connect this with a battery once again. Okay, see, and all of a sudden I have connected a LED here. Okay, so positive, negative, positive portion will apply here, negative will apply here. Obviously the atoms and electrons like this have the flow, positive this way, electrons this way. And once if the positive particles flow in this direction, the negative can flow in this direction, then we will have the flow of electricity there, and this LED will start yellow. How? We have connected this portion with the positive and this portion with the negative. Also give me some example, the electrical wires we are using, always we use copper, aluminum, iron. These are the good conductors of electricity, and this is how we can have the movement of particle inside it, and always particle flows towards these positive and negative electrodes and cathodes respectively. And because of the movement of these particles generally we say it as the charged particles, and I have already told that. For the details you can go through the previous video of ourselves. So the movement of these particles have created the flow of electricity from this material, and because of the flow of this electricity, we can say that the material is a conductor of electricity. As we all know that on the basis of electrical conductivity, we are having three types of material. See, types of material on the basis of electrical conductivity, and the basis of electrical conductivity means either they are conductor of electricity or not. So this is the example of conductor, this is the example of semiconductor, and this is the example of insulator. So we can say that always we are having solid materials in three types. First, conductors, second, semiconductors, third, insulator. So what is the meaning? That if we can see again, let me rub it. So we have discussed free electron and so a lot. If you see it, if I am applying temperature to any material and this electron is coming out, but remember one thing, it is not necessary for all the materials at all. It is not necessary for all the materials. How? If electrons is coming out easily, I am saying electrons means from the multiple orbits, from the multiple atoms, if electron is coming out from this orbit, conductor materials, free electrons are there, charged particles are there, so the electricity can pass through easily. Electricity, the motion of charged particles. If charged particles are there, so then the electricity will flow. Second condition, if particles are not coming out from their orbits at all, means we have applied temperature to it. For example, board, we are applying temperature to it. After some time it will burn, but the free electrons will not be generated there. The electrons will not be come out from their orbits at all. Rubber, it can lose its shape, they can lose their identities, but the electrons will not come out from their orbits, and this is the bond. The important portion is that bond. if bond is heavy there, obviously this is the example of copper, I am not saying that this is the wood or rubber and so on. But the bond, if the bond with nucleus and electron is too high, is too having huge amount of forces in between them, attraction force, electrons will not come out from the orbit. Insulator. While if applying some temperature, energy and so on, if electrons are coming out, conductors. So these are the two types, conductors and insulators. Another one type also, semiconductors, name semi, half. Half means at some temperature they will behave like conductor, at certain temperature they will behave like insulator. For example, silicon, natural semiconductors. We will have the class on this semiconductor in further lectures, have the detailed description of this. So, silicon material, silicon and germanium, they are having 4 electrons in their outermost core. So, at room temperature they will behave like semiconductors. While if we are increasing temperature around 50 or 60 degrees Celsius, they will behave like complete conductor. They will behave like complete conductor while going on the room temperature of below 0 degrees Celsius. While going in minus temperature, they will behave like insulator. So these are the temperature ranges. We can say that at certain temperature they are conductors, at certain temperature they are insulators, at certain temperature, room temperature, they will like half conductor, half insulator. The meaning of half is that if they are having the amount of free electrons, that is what the definition of conductivity. If electrons are generating easily, free electrons are there always, good conductor. If electrons are generating, creating because of some efforts, semiconductors. And if electrons are not free at all, insulators. Okay. So then after, we are also have to discuss 2 terms before going detailed description of types. The first one, if electrons, important portion, you have to highlight it. If electrons are in their orbits, if electrons are in their orbits, it means that they have not come out. All electrons are considered as the electrons in valence band. While if electrons are coming out, like for example, this electron has been come out, these are the electrons in conduction band. So 2 types of bands are there. So we can define that the motion, movement, description of any material. If electrons are in their orbits, are in their original places, electrons are in valence band, particles are in valence band. While if electrons are coming out from their band, if they are free, we can say that the free electrons are in valence band, conduction band. See, so this is what the description of, or we can say that the type of materials on the basis of electrical conductivity, and description means if they are conductor, semiconductor or insulator. See, these are the electrons and this is the valence band, this portion is the valence band, this portion is the conduction band. Obviously, see, these are the electrons in conduction band, meaning in conduction band means free electrons, not in their original places. Or if electrons are in these regions, see, valence band. Okay. So let me describe you. In the case of solids, the conduction band and valence band means defines by the amount of energy required to create free electrons. See, in the case of conductor, there is no need to apply additional energy, no need. Just a few amount of energy. Let me take you 0.01 electron and always free electron system. They will travel from this place to that place. Obviously, if we are applying some additional energy, there will be more and more free electrons. I am not saying that not required at all. It is required, but depending on one thing, that is the gap. The second one, obviously, in the case of semiconductor, there is a narrow band gap. Means they always require minimum amount of 1 electron volt energy, sometimes less, 0.7 volts for silicon and germanium. Germanium 1.13 electron volt, but on an average 1 electron volt is required so that we can have the electrons in conduction band. while we are applying the huge amount of energy, see, plus 5 electron volt, this is also not sufficient to create electrons to go in this conduction band. They will not go at all. So these how we can classify the various types of materials on the basis of electrical conductivity: conductors, insulators, obviously, and semiconductors. So for this particular lecture, the electrical conductivity has been described to you, and this is how we can say that how good conductor a material is, or we can say that the material is conductor or not, and these all are the basics of any electrical networks. So for today, thank you so much for your kind attention. This is Dr. Rahul Srivastav signing off. Have a nice day.